Sorry about that. All right, so it tells us that at time equals 1 second, we're as close to the wall as we're going to get. So we know that's a coordinate point. So we're going to plot that coordinate point here on our graph. All right, so I'm going to plot, I know at 1 second, since that's 1, I know my y-axis is over here, I'm at the closest I'm going to get. So 50. So I can plot that point. Now, when I do these, I need to label my x and y-axis. Okay? Since this is 1, my x-axis is going to be time. If you want to be more specific and say in seconds, you can. The y-axis over here is going to be distance. If you want to be more specific, distance from the wall, not necessary. But if you're not very good at word problems or word problems scare you a little bit, it makes it a little bit easier.
Do we put units?
If you want to. I do not care if you put units or not, but if you want to, it might be helpful so you don't forget the letter, but it's up to you. Time and distance, that's the minimum that I would expect to see. If you want to do more than that, then that is fine. You could even say in seconds, you could say distance in centimeters. Up to you how much more you want to put on that. Okay? So the reason I put the 50 right here is just because I don't have a lot of room right here. So I don't want to put the 50 way up here because then 160 is going to be even higher and then it's going to be in the words. Okay? So I know that at 1 second I am 50 centimeters from the wall. A lot of people want to start at 0 on these. They're like, I'm going to start at 0. Well, you don't know anything about 0. It does not say anything about where the pendulum was at 0 seconds. So that number does not help us at the moment. You can find it later, but right now we don't need to do that. Then it says 3 seconds later, it's at its farthest point, which is 160. All right, so where do we think that farthest point? We know 160 is up here. Is it at the second, third, fourth, or fifth point right here? Third, fifth? So would this be the farthest point away?
Oh, no,
or this? Good, it's the third. That is correct. Okay, so a little bit tricky because we think farthest away, and our first thought is to go this way. But remember, this is time, so that's why if you label those, it just makes it a little bit easier to think about. Our farthest point away, and if we think about a sinusoid, this is the lowest point. We have low, middle, and high. So if this is low, our next point has to be middle. Our next point has to be high. Then we have to go back to the middle, and then we have to end where we start if we're going to draw one cycle. So we can draw this graph. Now we need to do some more stuff before we can write an equation. Just because we have a graph doesn't mean we can write an equation. Bless you. All right, so when it was at its highest 3 seconds later, so what's that, would that time be? 3. So is that 3 seconds later? 4. 3 seconds later. Since we started at 1, 3 seconds later would be 4. Yes?
Wait, how did you know that point was at the middle?
Because our choices for sinusoid are high, middle, and low. Those are only 3 points for sine and cosine. So high, middle, and low, since we started at our closest point, it's not going to get any closer to the wall than this. We know we have to go to the middle. And then after the middle, we have to go high. And after high, we have to go middle. Low, middle, high, middle, low, and then just do that forever. Okay? So then if we go from low to high, high to low, if it's varying sinusoidally, that means it's staying the same. So therefore, this would be 7. And then label the rest. So 5 divided by 2, or 2.5. 11 over 2, or 5.5. Either one would be fine. Only other thing we need to label on here is this middle. If you like that dashed line, put that dashed line through there. We need this value right here in order to write our equation. Add and divide by 2. 105. So now we have everything we need to write the sine or cosine function. Now, if I look at that, if I just look at that graph, my first thought is that's cosine graph. Okay, but remember, this keeps going. Whoa, I don't want to do that. This keeps going like this. This would keep going. Now, I'm not going to draw it any further than 0 because we can't have a negative time, but the graph keeps going on and on forever. Okay? But I'm just going to focus on what I know. I don't care about doing anything extra because then I just have a better chance for making a mistake. So I'm going to either write a sine or cosine. If I choose to start right here, that's low. Low and high is cosine. Low is a negative cosine. High is a positive cosine. Doesn't matter where you start. If you start in the middle, then you write a sine functions. Middle goes high is positive sine. Middle goes low is a negative sine. I usually start at the middle. At the beginning. I'm going to start at the first point that I plotted. You can start wherever you want. So if I start at that first point I plotted, I'm going to write a function. So I want to be sure and do that in function notation. So that is d of t, because the letters were given to us in this problem. We have to use the letters that they gave us. We can't make up our own letters unless you state somewhere that you want to change the letters, which I don't suggest doing, because then you just get confused. All right, so since I decided to start down here low, that would be negative. Then I need my a value, in this case the amplitude, so 105 up to 160. It is 55, correct. And I chose low, so that's cosine. Now I need my period. Now I'm going to put this little bracket. You don't have to put those brackets there. You can just put the b value, but we have to find the b value using the period. The period is one cycle, 1 to 7, so our period is 6. Therefore, 6 equals 2 pi over b. Now, if you want to use 360, could you? You can just pick whatever you want to use, degrees or radians? No. Are there degree symbols on the x-axis? Nope, so we're going to use radians. And we've never done a word problem in degrees. The problems we do in here will all be in radians, so these word problems will always be in radians. Okay, any word problems that we do in here will be in radians. I'm sure there's degree ones out there, but ours in this class will be radians. So we solve for b. If we need to cross multiply, 6b equals 2 pi. Divide by 6. So b equals pi over 3. So that's what goes here. And then again, use the correct letter, t. I chose to start right there, so that's minus 1.
Do you take a theta or y or anything?
Not on this one. Okay. Unless you state that you're changing d to y and you're changing t to theta. Okay? Then plus 105. So there is your equation for that one. Again, those brackets, those don't have to be there when you write it. Now, the calculator, that's a different story, but when you write it, you don't have to have that extra set of brackets right there around the t minus 1. Remember, if you don't like negative and you'd rather write it positive, start at 4. That'd be a positive cosine. So if this was t minus 4, your 55 would be positive. You could start at 7. T minus 7, it'd be negative. Or you could start at 2.5, and that would be positive 55 sine t minus 2.5. All of those are correct. Lots of different, infinite number of correct ways to write the equation. That doesn't mean all of them work. Your c value, wherever you choose to start, will determine what your plus or minus is out in the front. All right, now the next part of that is using that equation to answer some questions. Now, I've said this over and over again. I'm going to keep saying it. Calculator or non-calculator, all depends on the numbers that we give you. So I'm going to show you how you can do this without a calculator. This first one can be done without a calculator. It doesn't mean it wouldn't end up on a calculator. We could change this. If I change this to after 8.2 seconds, now maybe it becomes a calculator problem. But at 8 seconds, we can use we don't need a calculator. So what we do is we plug in 8 seconds for t. So negative 55 cosine pi over 3, 8 minus 1, plus 105. And then I just do that math. So that becomes cosine of 7 pi over 3 plus 105. Now, 7 pi over 3, you might think, okay, 7 pi over 3 is not on the unit circle. But remember, anything that has a 3, a 6, a 4 in the denominator, we can find on the unit circle. Two different ways to do that. Okay, so on our unit circle, we could count. If we count, we're counting by sixes. So that means this needs to turn to 14 pi over 6. All I did was multiply by 2 over 2. So remember, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or we could just start at 12 because we know that's 2 pi and we know that's bigger than 2 pi. So 12 pi over 6, 13 pi over 6, 14 pi over 6. So 7 pi over 3 is coterminal to pi over 3. So another way to think about that, 7 pi over 3 minus 2 pi, 7 pi over 3 minus 6 pi over 3 is equal to pi over 3. So 7 pi over 3 and pi over 3 aren't equal, they're coterminal. They land at the same place on the unit circle. And if we want the cosine of 7 pi over 3, what's the x value right there? Correct, 1/2. So negative 55 times 1/2 plus 105. We could say that's negative 55 over 2 plus 210 over 2. So 155 over 2 centimeters, 77.5 centimeters. Either one of those would be correct. But we could also plug it into the calculator. Okay, that's also another option. Is if this was on a calculator section on your test, then just plug that in. But it is important in the calculator. We're going to do this next question because this next question does require us to use the calculator. It is very important that you type it in correctly. Lots of people have made just very minor errors. Forgot a parenthesis, used a negative sign instead of a minus, put a plus right there instead, and it throws your answer completely off. So it is very easy to make a minor error that causes everything to be wrong. All right, so first, we clear your calculator. It needs to be in radian mode because we're pressing the cosine button. So these word problems are always in radians. So if you're not in radians, you're going to get some crazy answer that might not make sense. So we're going to go to y equals. And we're going to type in negative 55 cosine. Now, some of you can make yours do the fraction, like the top, the line, and then the bottom. That's fine. Mine doesn't. So I need to open an extra set of parentheses to put the pi divided by 3, close, open, x minus 1, close, close. Very important that you close that again. Especially if your calculator, if you're not doing the x and then the line, the 3. The division bar, not the side division bar like that. And then plus 105. Again, make sure you're in the right mode. Must be in radian mode. If in your degrees, it's going to look like a line. Because radian, think when one cycle is 0 to 2 pi, which is like 6. But if you're in degree mode, one cycle is 360. So 360 is this big, and then 6 is like that big. So you're only seeing a very little part of the graph, so that's why it might look like a horizontal line. All right, so then I'm going to graph it. Just to see what it looks like, see if I did it right. Well, it's not graphing, so my calculator must be broken. No, it's not broken. Okay, let's think about this. We drew a picture of that graph already, right? Right here. Okay, so my calculator, why is it not showing this right here? Well, because this is 50, and our calculator defaults only goes to 10, negative 10 to 10. So that's why I can't see anything, because the max number I see is 10. So I'm going to go to my window and adjust it to look like this graph I drew. So the window's right next to y equals. And I don't care about negative time, so I'm going to start at 0, and then I'm just going to leave the x max at 10 so I can see a little bit further over. Then my y min. So I need to see between 50 and 160, so I'm just going to make that 0 to 200. You could have left it negative 10 and gone up to 160, or just anything above 160 or above. Now when I graph it, I can see that graph because I've changed my window according to the picture that I drew. Now, the question says, when is the first time the pendulum is 150 centimeters from the wall? So let's look at our graph we drew. Well, here is the first time it's 160. We want to know 150. So 150 is a little bit below. So if we say, when is it 150? Right there, there's the first time it's 150. There's the second time it's 150. Remember, this graph continues. Then there's the third time it's 150. The fourth time. It's just going to keep being 150. 150 on the way out. 150 on the way back. On the way out, because it goes all the way to 160, so 150 crosses on the way out and the way back. So how do we figure that out? We want to know, when does the graph, this is the pendulum, when does it hit 150?
You plug the next one into 150.
Absolutely. Yep, so we go to y2, and we put in 150, and there's that line. So we want to know, when do they intersect? The first time. Second, trace 5. No different than when you started finding intersections of lines in Algebra 1. Now, we need our cursor to be closer to our point we're trying to find. If you just move the up and down arrow, all it's going to do is go from one graph to the other. Up and down doesn't do anything but go from one graph to the other. So we have to go over here. Doesn't matter if you get there on the curve or the straight line. And again, you just have to be close to that point. Then enter, enter, enter. And you get your answer of 3.415, and we are in seconds. So 3.415 seconds. If it had said whether the first 2 times it hits 150, we would just do that again. Second, trace 5. We'd scroll over to the second time it hits 150. Enter, enter, enter. And we would get the second time. The third time, we do it again. The fourth time, again. And keep going. You could do that forever. Questions on that part of it? The hardest part on this usually is typing this in the calculator correctly. So this right here, all these brackets, if you want to just write them all the time, that way it helps you put it into the calculator, then do that. If this is something other than a single number, that's 2 things. It needs its own parentheses, because if not, what happens is it finds the cosine of pi over 3, which is 1/2, and then it takes 1/2 and would multiply it, like this one would multiply 1/2 times 7, and then we get 7 over 2 right here. And then it would multiply 7 over 2 times negative 55. And so that's why order of operations and all those parentheses are very important. The calculator follows order of operations. So if you don't set up your parentheses correctly, it won't give you the correct answer. All right, and then the last one for today, water wheel. So these problems, it could be a water wheel, a Ferris wheel, a bike wheel, a car wheel. Anything like that could be a problem like this. This problem, a water wheel, is going to go under the water. But if you're doing a Ferris wheel problem, would a Ferris wheel hit the ground or go under the ground? No, so its low point would be raised a little bit. But a car tire or a bike wheel, that would hit the ground, so it would be right at 0. So just something to kind of think about while we're doing these problems. Now, this one does not require you to solve anything about it, so we don't even need a calculator on this problem, I don't think. All right, so the situation is a water wheel rotates at 6 RPMs. Now that's going to be important in a second. Right now, we're going to skip that. But that's going to be important in just a second when we find our period. Revolutions per minute. Revolutions is going to be important for finding your period, which is one cycle, which is one revolution. All right, so we start our stopwatch. That's time equals 0. Do we know anything about the height when time equals 0? No. So that information is just extra stuff that we don't even care about. But this next one, 2 seconds later, so 2 seconds after we start it, so that's at 2 seconds. So we know at 2 seconds, we're at the greatest height. Now, this one doesn't tell us what the greatest height is. We have to get that from the picture. Now, this picture, here it has the water. So it tells us that from the water up to the middle is 6, and then it tells us that the radius of this circle is 7. So what would this, when the point gets to right here, what would that height be? Be what? 13. Good. It'd be 13. Which leaves 1 foot right here below the water. So what we're going to do up here when we graph it, so we have 2, and then we know 13 is our greatest height, so we can go ahead and say 13 and plot that point. Always start with something you know. Plot a point that you know. It doesn't matter if it's the highest, the lowest, the middle. Just do what the problem says. Don't make up something that you don't know. Now, if we know that's the highest point, what do we have to do next? Middle or low? Middle, low, middle, high. Okay? So we know our low value because we know the diameter of this right here is going to be the diameter of the circle. The highest is 13. The diameter is 14. So we're going to go down to -1. That's where that -1 comes in on that picture right there. And then we're going to have some middle right there. So we know it's middle, low, middle, back to high because we have to end where we started. But now we need some information to fill in order to write the function. All right, so first we could figure out what that middle value is, right? 13 and -1 divided by 2. 6. Okay, so that's kind of tricky on this one whenever we have. So the radius is 7, so that means this distance is 7, which makes this 6. Okay, so be careful on that when we talk about the radius. Like if we say, the one on your homework talks about Ferris wheel being, I don't know, say it's 70 feet in diameter. So then the middle's 35, but the middle is not 35. The middle of the Ferris wheel is 35, but if it doesn't hit the ground, that's going to be changed. So from the middle to the height is 7, so that makes the middle 6. Now what we need is the x-axis, so that's when this RPM comes in. So we know that that is 6 revolutions in 1 minute. We want to know how long it is for 1 revolution. We don't want 6. Well, we know it's going to be seconds. Some of you can just come up with that easy. But if you can't, this is what I do. Okay, so, well, 6 revolutions happen every 60 seconds. I could change 1 minute to 60 seconds. So now if I simplify that, divide by 6, I get 1 revolution every 10 seconds. And 1 revolution is a cycle, and a cycle is the period. Okay, so I just figure out what 1 revolution is. 1 revolution is I started high, and how did I get back to the high point? That was 1 revolution, and it took 10 seconds. So this would be time. If it took 10 seconds, we started at 2, and we went to 12. Say that again? 7.
Oh, I was just doing the middle point.
Oh, this?
No.
Oh, this.
Yeah.
Got you. Yes, 7. Forgot to label this, so this is distance. If we wanted to be more specific, distance from the surface of the water, if you want to be a little more specific on that. then 9 over 2, or 4.5. 19 over 2, or 9.5, whatever you want to say. So now we have everything labeled. We can go ahead and write our d of t. It gave us those letters, so we need to use those letters. Equals. When I look at that, I see a positive cosine. Again, I usually start at the first point that I plot. You can start wherever you want, though. But depending on where you start, depends if it's sine or cosine, and depends if the sign in the front is plus or minus. So since I started at 2, that's a high point, so that's going to be a positive 7 cosine, correct? And then I have to find my period using, or find my b value using my period. So 6 equals, no, we're at 10. 10 equals 2 pi over b. 10b equals 2 pi. Divide by 10. Always reduce. Pi over 5. Our variable is t, given in the problem, minus 2, and then plus 6. So there is your sinusoid. Sinusoid can be sine or cosine, either one. I usually start at the middle, the first point, whatever the first point is that I plot. Not necessarily 0. It might be 0. It could say we started timing at time equals 0 seconds. We were at the very bottom, or we were in the middle, or we were at a height of 12. Okay, it might tell you that, but if it doesn't, only plot what you know and start plotting with what you know. It'll be much